Okay. Sorry about the delay, everyone. I don't know if anyone saw the message in Discord, but the Great Hall is currently in use for a meeting. So I instead am using this hallway whiteboard. Okay, so we have questions for already asked about question homework 5. And then in Discord, you said you also have a question for homework 5. Which particular part?
I just need help on like how to start these questions because I can't really understand what it's asking me to do.
Okay, all right, fair. And then someone else joined. Okay, yeah. Good Noodle, did you have any questions?
No questions so far.
Okay,
I'm good.
cool. All right, so yeah, we'll just go ahead and start with number 1, just beginning with that one, and we can kind of go over how to start that process. Then I'll let you guys go from there. So for number 1, we have to make an FSM that detects 2 distinct sequences, as opposed to just one. And we also have to use one hot state encoding. And I believe you're supposed to use a Mealy FSM for that one, instead of a Moore FSM. So we're going to do Mealy. And we'll go through what the difference is between Mealy and Moore before we kind of dive into this. So, before I start writing on the board, do you guys know what the difference is between a Moore and a Mealy FSM? Yay or nay? Okay, I'll take that as a no. So I'll go ahead and bring up a few differences between Mealy and Moore. So as you might have gone over in lecture, Moore is the one that is most commonly used. That'd be around 95% of the FSMs that you'd normally be doing. The main difference between Moore and Mealy FSMs are that when you have a Mealy FSM, your outputs are asserted on transitions as opposed to in states. So typically, in most of the FSM designs you guys have been doing so far, whenever you write an output being asserted, you write that within the little state bubble. But for Mealy, you don't write it on the state bubble, you write it on an actual arrow. And so the way you do that is on an arrow, you draw the input that led to you taking that arrow, and then you do like a little slash, and then you'd write the output that arrow would correspond to. And typically this has the effect of reducing the number of states you need for your FSM by 1, so you can essentially omit the final state, because instead of going to that state, outputting, and then going to reset, for example, you would go to reset and output in the same cycle at the same time. So it saves you out 1 extra state. The issue with this, and the other difference between Mealy and Moore FSMs, is that when you have a Moore FSM, you're used to doing the next state table and the output table separately, because the next states depend just on the current state in the input, and the output just depends on the current state. But for Mealy FSMs, the output depends on not only just the current state, but also the inputs as well. So the trade-off for Mealy is that while you do have 1 less state to work with, that'd be having your register size 1 smaller, while that is the case, you also have to account for the fact that your output logic will be slightly more complicated, because you have to take into account the inputs as well as the current states. So those are a few of the main differences between Mealy and Moore. And so I'm going to start by drawing on the board. And I'm going to try to draw big because I know it's probably going to be kind of difficult to see. It's a little far away, these tables, from the whiteboard. So if you guys can't see it, just let me know. But I'll start with writing down the patterns we're supposed to be detecting. And then we'll go from there. The other pattern is 10110. All right. So in order to detect these 2 sequences, it's not showing up too well on the camera. Well, I'm sure you guys have the homework up in front of you, but in order to detect these 2 sequences, we've done a problem similar to this on one of the previous homeworks. I think it was homework 4, where again you make an FSM to detect 1 sequence. Now, if you're trying to detect 2 separate sequences, you could try and make 1 FSM to detect both. That's a possibility, and you could do it. The only issue with that is that it would be pretty complicated to keep track of both sequences at the same time. With 1 FSM, you'd have lots of transitions, lots of states, and it kind of just makes your job a little harder than it needs to be. because what you can do instead is treat it like two separate problems. Break up your problem into two easier ones. So instead, what you can do is you can make an FSM to detect just the first pattern, and then make an FSM to detect just the second pattern. And at the end, now you have a system that is able to detect either pattern. And remember that the goal of this this question is to essentially figure out if one or the other pattern has occurred. So we just need to detect if one of those patterns has occurred. So at the very end, when you have your output logic, the output logic of the first FSM is going to say, okay, I've detected 0, 1, 0, 1, 1. And the output logic of the second one is going to say, okay, I have detected 1, 0, 1, 1, 0. If either of those sequences are detected, we output true. That's the entire purpose of this. And so all you have to do is you take the output signal of one of the first FSM, the output signal of the second FSM, and you run them through an OR gate, because you want the output, the final output, to be true if either one is true. So if the first one is asserted or the second is asserted. And so pretty much that's the main point of this problem. It's essentially trying to show you that you can take one big problem, split it into multiple pieces that you know how to do. And we know you know how to do this because you did this exact problem on the previous homework. The only difference is it's a different sequence, and it is a Mealy FSM instead of a Moore FSM. Okay, so now we're going to get into drawing out the FSM. I'll do it for the first sequence for 10111, 01011. So I'll go ahead and start the FSM for that one. And we'll talk about the differences when you're creating your diagram between the Moore, which you're used to, and the Mealy that we're going to do now. And then after we go through the entire diagram of that first sequence, you guys can do the second sequence yourselves. So we'll start with that first one. Okay, are you guys able to hear me from over here?
Yes.
Okay, cool. Let me know if I cut out or if you can't hear me or whatever. So I'll go ahead and start with the reset state, which is present in almost all of your FSMs. You're going to have some sort of reset state you want to go back to. And when you're in your reset state, we need to ask ourselves, where can we go? So there's only two possibilities for our input. I'm going to call the input A. It's alright if you guys can't see that. All I did was I just said the input signal is called A and the output signal is called D. And what I'm going to do is I'm going to ask, okay, where do I go if I receive a 0? Noting that the sequence I want to detect is the first one listed, 0, 1, 0, 1, 1. Where should I go if I receive a 0?
Wait, sorry, could you repeat that?
Yeah. So if I receive a 0 as my input, where should I go? Should I go back to the reset state? Should I go to a new state? What do I do?
Oh, you go to the new state.
Yeah, you go to a new state. And just for the sake of naming, to make it easier for us, I'm going to name the new state S0 to represent that we've just received a 0. Now, it might be a little difficult to see, but what I've drawn is an arrow to interconnect the two, let me zoom this in. There we go. So I've drawn an arrow. Oh, you can't see that at all with the brightness, huh? That's better. So I've drawn an arrow between the two states, basically just saying that the left one here, that's going to be the input, and the right one, that's going to be the output. They're separated by a little slash if you can't see it. So my input that I received was A equals 0, and my output is 0 because I haven't detected my sequence yet, so that output's always going to be 0. Just like in your Moore FSMs, you don't even put zeros within the states because you assume that if there's nothing written in the state, it's automatically 0. But for Mealy's, you have to directly say, hey, it is outputting 0. And so every single one of these transitions is going to have both an input and an output. Slash. Did anyone have a question?
None for me.
Okay. So we'll continue on, and I'll ask, if we're in the reset state and we receive a 1, what should we do? Where should we go?
You stay in the reset state?
You stay in the reset state. Yeah, you haven't actually progressed through your sequence yet. So you haven't detected the first bit. That means we stay in reset. We haven't detected any of the first part of our sequence. Let's see if I move off to the side, it gets a little better. So now what I'm going to do is I'm going to go ahead and go to state S0, and I'm going to consider the two possibilities going from there. So if I'm in S0 and I receive a 0, where should I go? And why?
You would remain in S0. So
You would remain in S0, that's right, yeah. Because we just received 2 zeros, so that second 0 could still be the start of a new sequence. That's right. Notice that again, for the second bit after the slash, I'm putting 0 because we're not asserting that the sequence has been found yet. And what if I received a 1 at this state? What would I do? It looks like someone has been trying to unmute in the Discord, but their audio's not coming through, so you might be like muted on your computer, but not on Discord or something like that, just so you know. But yeah, if we were in state 0 and we received a 1, where would we go?
you would go to the new state.
Okay, there you go. The next
cool.
state?
Yeah, we'd go to the
state
new
1.
next state, that's right. And in
Okay,
this
now I
case-
can't even hear you.
You can't hear me? Oh, geez. Okay, well. Anyways, you were correct. Both of you were correct. We would go to the next state, and I'll call that state. I can hear you, yeah. And the next state we're going to call S01 because I first received a 0 and then I received a 1. Okay. So now that I have that state written out, I need to then consider all of the possibilities from this new state. Because we've done both possibilities from the reset. We've done both possibilities from S0. Now we need to consider from S01. And so again, we ask, well, what happens if I get a 0?
We go to state 010.
Exactly. We go to the new next state, S010, named so because we've received a 0, then a 1, then a 0. So with that drawn in, what if we instead received for example, a 1 when we were in state 01? Where would we go?
We go back to the reset.
We'd go back to the reset, that's right. So if we look at the most recent bit we just received, it was a 1. That doesn't match the first part of the sequence. The first part of the sequence is a 0. And then if we look at the two most significant bits, that's going to be, well, we just received a 1 and then another 1. 2 1s consecutively. That doesn't match the first part of the sequence either. First part of the sequence is 0 1. And it doesn't match the third part of the sequence or the fourth, and so on. So we have no matches, so we go back to the reset state. All right, so now for the next step, I'm going to ask, again, we're in S010, and we need to know where we're going to go depending on if we get a 1 or a 0. So if we get a 0 from here, where do we go?
We would go to state 0.
We would go to state 0. I think I agree with you on that. If we look at the most recent bit we just got, it was a 0, and that matches the first part of the sequence, which is a 0. So that could be a new starting point for our sequence. If we went back to reset state, and that was the new starting point for our sequence, we would miss out on that sequence, and we wouldn't be able to detect it properly. So I'm going to go and draw that up. And then I'll finish up this one for you guys. So if we get a 1, we're going to end up moving on to the next state. And then finally, for the last state, and I say this is the last state because after this point, we will have either received the full sequence or we're going to reset somewhere back to one of the previous states. But for the moment, let's assume we've just received the full sequence. So we just received another 1. So we got 0, 1, 0, 1, and we just received a 1. Because we've just received a 1, that means we want to output true because we've just detected our sequence. Now, like I mentioned before, for a Mealy FSM, you don't output within a state, you output on a transition. So in all of the FSMs you've done up until now, the purpose of that final state has been to output your signal as true. But in this case, because we can do that on a transition, there's no need for the final state. So instead of having a sixth state here, like you would in a Moore FSM, you're going to draw an arrow straight from here to wherever you would go next, instead of that final state. And within that transition, then you finally assert a 1. So if we received a 1 at the very end, and we have the sequence 0, 1, 0, 1, 1, we will draw an arrow which outputs a 1. Where would we draw that arrow to? That is the question. What do you guys think? Where would the arrow go?
Would it go state 0, 1?
Let's see. So if I had, let me go ahead and I'm going to try and write this big. If I have just received this sequence of bits, the first thing I need to ask myself is, well, does the most recent bits match up with any part of my sequence? So I've just received this. My first bit does not match the first bit of the full sequence. It's not a 0. My most recent 2 bits do not match the first 2 bits of my sequence. My most recent 3 bits do not match the first 3 bits of my sequence. My most recent 4 bits also do not match. So what that means is I don't have any possible starting location for the next sequence that I could possibly detect. Since it doesn't match at all, that means I would go right back to the reset state. Now, once we have that down, we can talk about what happens if we don't get the full sequence. So let me write this one up first, though. It might be a little hard to see, but if you'll notice, on that transition back to the reset state, I actually wrote 1/1. The first one is to represent that we received an input as a 1, and the second one is to represent that we just output a 1 because we detected the sequence we were trying to detect. So now I need... Yep, what's up?
I was going to ask, so we don't have the assert 1 on its way to the state 0, 1, 0, 1, 1, but we instead assert 1 on the output whenever we're going to the reset?
We assert 1 if our sequence is detected, and in this case, in this state, we've just received 0, 1, 0, 1, and then this transition represents that the most recent bit we just received was another 1. Well, that means that we've just detected our sequence because we had the first 4 bits, and we've now just received the final 5th bit. That's the reason why this is outputting a 1. Not necessarily because it's going to reset. This could have possibly gone to this state instead, to state 0.
Okay.
So now we're going to talk about the case where we didn't detect the sequence. So we got 0, 1, 0, 1, 0. Does that look like any part of our sequence as up to this point? If we have just received a 0 at the end, what state would we go to?
State 0?
Good answer, but we can actually do better.
0, 1, 0.
Yes, 0, 1, 0. Because if we look at the sequence we just received, one second. Yeah, you want to say hi to the 200
Hello.
students there in the Discord?
I'm
This is
your
your guys' grader.
I'm your grader. Hello, AJ27. We talked like yesterday or 2 days ago.
Okay. So, like I was saying, if we've just received a 0 for the 5th bit, we need to again ask ourselves, which part do our most recent bits match up with for our original sequence? So 0, yes, that does match up, because 0 is the first bit of our sequence. But we always need to make sure we can't do any better than that. The first 2 bits don't match up, because the first bit isn't 1, the first bit's 0. But these 3 bits, the most recent 3 bits, well, it's 0, 1, 0. And in our actual sequence, the first 3 bits are 0, 1, 0. So, in actuality, while you could go to state 0, you might miss out on a sequence if you did that. Because 0, 1, 0 could be the first 3 bits of a new sequence. And so, that would be the correct answer, 0, 1, 0. So I'll go ahead and draw that in on the diagram, and then you guys can ask me any questions after I finish drawing it. And again, as a small side note, I have the arrow going backwards, outputting a 0 because the sequence wasn't actually detected. Okay, so any questions on that? Because we've just finished the full FSM design. I think, yeah, the only thing I've left out is the reset signal feeding into the SR, but you'd have that on all of your FSMs. Just don't forget that. I did. But any questions for me?
I have a question.
Yep.
So, like when you look at your last input, and if it's true, that means you start to like read your input from like right to left to see if it fits into the other states first.
So essentially, in this particular case, whenever you have a mismatch, meaning like you don't progress the way you want, if you're not detecting the sequence that you wanted and you got like a wrong bit, then yeah, you would go back and see, okay, which state would I have to go back to? And that's where you would check the, like I was saying, the most recent compared to the first bit, most recent 2 compared to the first 2, etc. That's when you would do that. Not just on the last one, but on all of the steps where you have a misstep, where you get the wrong bit.
All right, that makes sense. Also, you said to not forget to do what?
Oh yeah, draw the reset. I'll show you. You got to draw the reset signal.
Okay.
That's just something you would have in pretty much every design, a reset signal, because whenever your system starts up, you want to have it in a known state, so it's not behaving erratically. And so when you start up your system, your reset is going to be on for a few, microseconds or however long, and then you're in the SR state.
All right.
So I'm sorry.
No, you're good.
So,
What's up?
I was gonna ask for whenever we do the thing wherever like we have the wrong input, and then like we try to see if we can go to the back to for like the 0, 1, 0 or whatever. Is that only for melee FSMs, or can you do that with more FSMs
No, you do
too?
that for more as well. You do those for more as well.
Okay.
Yeah. And it just happens that that's the way we kind of think about it for this particular kind of FSM. And when I say this particular kind, I mean the sequence detecting kind. If you're trying to detect 0, 1, 0, 0, 0 or whatever, that's just one of the ways to think about which state you should end up in.
Is there any exceptions to this?
To what?
Where you would like not want to do that if you like to just go back to the reset if you don't get the correct.
Question. So if you don't want to consider overlapping sequences, that's when you would consider it. So for example, for this sequence, it's 0, 1, 0, 1, 1, right? Let's say instead the sequence was what I have labeled over there on the board, 0, 1, 0, 1, 0. Well, it's pretty easy to tell that you can have a lot of overlaps with this. If I just put an extra 1, 0 at the end, you'll notice that those are actually two distinct sequences. There's the first 5 bits, 0, 1, 0, 1, 0, and then the second, the last set of 5 bits, 0, 1, 0, 1, 0. And those are overlapping sequences. So then it becomes a design question. Do you as the designer want to detect those as two distinct, separate sequences? Or do you want to not consider overlapping sequences? If the answer is, I don't want to overlap my sequences, then you'd be right. We would go straight back to the reset state. If you do, then we do the process we've been talking about where we consider which state we would end up going to. Okay. Does that kind of answer your question? Okay, well, if you have more questions about it, just let me know. I don't know if you're muted or not on your side, but for everyone else, does anyone else have any questions about the process for this, or just in general? Okay.
Not from you.
All right. So what we'll do then is now you guys can either do, well, here's what we'll do. We'll just continue with the design process from this one, because at this point, now you should be able to do the other FSM yourself in an identical process to this. It's just a different sequence. For the other one, it's, I forget what it was like 10110, I think. And the process is almost identical. You will have a few different transitions, but the overall way to do it is exactly the same. And now we can move on to the next portion, which is what? What comes next?
State transition table.
Exactly. However, that would be if it was a more FSM. For a melee FSM, remember that your next, well, I'll just mention this. Remember that your outputs also depend on the current inputs. So instead of having two separate states, or two separate tables, one for the next state and one for the output, we can actually have them all in one table instead, because the outputs are also going to depend on the inputs as well as the current state. So typically for melee FSMs, you do one big table with both next states and the outputs on it, instead of two separate tables. So that's what we're going to do. I'm going to take a picture of this, and you guys can take a screenshot if you need, if you haven't written it down yourself, though I would recommend writing it down. So I'm going to take a picture, and then I'm going to erase it so I can drop the tables. Or the table. Okay, I'm going to go ahead and erase the table. Or the chart. Okay, so I'm going to go ahead and drop the table for the inputs, current states, next state, and output, all as one big table. So I've went ahead and drawn the columns for my table. I have the input side, which is just A. That's the input bit that I keep receiving, telling me what the next bit is for the sequence. And I have C.S, that's for the current state. N.S, that's the next state. And then the final one over there, if you can see it, is just the letter D to represent detected, which is going to assert if the sequence has been correctly detected. And so now what I'm going to do is I'm going to just look at my chart, at my diagram that we just drew up and I erased on the board. And we're essentially going to just take each arrow, and it's going to be one row on our table, just like we've been doing for the past few FSMs in class. So I'll start with the arrow that starts from the reset state, goes back to itself, and is when you have an input of 1. Alright, so you'll notice for this one that when I am in the current state, the reset state, and I receive a 1, I'm going to stay in the reset state, and I'm going to output false because I have not yet received the full sequence. And so what I'm going to do is I'm going to fill in these rows for every single one, except for this next one. I'm going to ask you guys which arrow I should do for the next row, and what I should write as well. So which arrow should I do next, and what would I write?
The input 0, output 0.
Yeah, that's right. So when you receive a 0, when you're in the reset state, and where do you go?
State 0.
And what do I output for D?
0.
Yeah, because that's the right-hand side of the slash. Yep. Okay, so I'll let you guys go ahead and write up your tables on your own. I'm going to write up my table up here in about a minute. I'm going to go use the restroom. I'll be back in a minute, but once I'm back, I'll finish writing up the table so you guys have some time to write it up yourselves. Alright, so I'm going to assume that everyone's most of the way through the table, not necessarily finished, and I'm going to go ahead and start writing up the table on the board, and then we can compare and see if everyone got similar results. So I finished writing up the table up on the board, so you guys should be able to see that, and you can compare it to your tables. If you guys notice any discrepancies, let me know. But I did check through it pretty thoroughly, so we can look through it again if anyone has any differences.
Are you speaking, or is my headset?
I'm not speaking, but you might be hearing some like background audio of like the fans from my computer or like people walking by or something.
Oh, okay. I thought my thing was muted because
No,
it keeps
I
doing.
wasn't. I wasn't speaking. Okay, so I'll just assume for the moment that most everyone has finished checking through the table and we're all in agreement. So we have our table for the next state and output equation, for the next state and the outputs. But what would we do next?
Encoding?
Yeah, state encodings. So we write down all of our state names. There were, I believe, 5 states that we had. Yeah, 5 of them, and we're going to encode them. And what encoding are we going to use here? Because I think it was specified
One
on the
hot.
assignment. One hot, yeah. I'm pretty sure it said one hot on the actual assignment. So I'll go ahead and write the one hot encoding assignment. And remind me, what does one hot mean again?
Only one is high at a time.
Exactly 1 bit is high for each encoding. That's exactly right. So I went ahead and written up the state encodings. So just as I assume most of you probably did, I went just in the order that our FSM diagram went in, and I labeled them 00001, and then I just moved the 1 over, shifted it up over 5 times, and that was my full state encoding. So now that we have both the tables we need, what are we going to do next? So what do you normally do when you have a table? Or a truth table?
We have to use the encodings now with the state transition table, but with the outputs as well.
Exactly, and then once we replace those encodings into the table, what would we do next?
I have a question.
Yep.
Are we not writing down the state for 01011? Or am I
Oh, that's a
not
good
saying
question,
it?
yeah. So I don't know if you remember from the full diagram that I had up there, but there wasn't a state 01011. Remember that for a Mealy FSM, our output occurs on a transition, so we don't need that last state because the purpose of that last state in a more FSM was to output that we detected the sequence. But because it's Mealy and that occurs on transition, there's no need for that last state.
Okay, I see.
So that is a good question, though. Yeah. What were you going to say?
Oh, I just said thank you.
Yeah, for sure. If instead this was a more FSM, we would have an extra row for that final state, and so our state encoding would take 6 bits instead of 5, because we would have 6 states instead of 5 states. And so now the last thing for us to do is for us to write those encodings in our table, which I'm not going to do up on the board just because it's kind of rote. You just transfer them over. But what I will do is I'll start by writing one of the equations. Specifically, I'll write the output equation because that's one of the easier ones. Because we're going to have to write two equations in this. We're going to have to write the next state equations and the output equations. Okay, so I'll start with the output equations, and here's the way it's going to go. I'm just going to, like in a regular truth table, because this is a regular truth table, I'm going to look for all my ones, and on each of those, I'm going to take a look at what my inputs are, and I'll use those as my for my equation. So my output D is true whenever I receive a 1, and I'm currently in state 0, 1, 0, 1. Note that SR here is not included in my equation because SR is part of the next state. That's one of the outputs. So that's not going to be considered in our state. Okay. So let me go and write the equation. Okay, so up in the top left there, I've written the output equation, which says the output D is equal to A and S4. Would anyone be able to tell me why I wrote just S4 and not the remaining bits in my state encoding?
Since it's one hot encoding, we know the rest of them are not going to be high.
Exactly. By definition of our encoding, we're using one hot. When we see that S4 is on, we know automatically that 3, 2, 1, and 0 are all off. So we don't have to include those in our equation, and we won't have to include that in our schematic and our hardware. So now what I'll have you guys do is I'll have you guys think about how you would get the next state equations. Again, it's the same as any other FSM. You would, like I said, replace these names with the actual encodings, and then you would find all the places where one of the columns is on, and write those in an equation in standard sum of products form. And then from there, you could either put it in a K-map if you wanted to, or you could write it in the equation, do some Boolean algebra, simplify. It doesn't matter which method you use. Yeah, and I think that's where we're gonna leave off. So you would write the equations, and once you have the equations, what's the next step?
Schematic.
Yeah, we draw our schematic. So we would take those equations and turn them into our schematic format. So remember that for your schematic, you have the register, the state register, which in this case is going to be 5 bits. So we'd have 5 wires going into it, 5 wires coming out to represent the state. For each of those input wires coming in, that's going to be your next state logic. So that's going to be the equations you get from doing all these states here on the table. And then once we have all of that combinational logic done, the next state logic, we have the register drawn. The last thing is the output logic. And so after the register, you would simply have a single AND gate according to this output equation. And that's just going to be ANDing the input A with the current state S4. And that is the entire process. So if you guys want, I can go through deriving the equations, but, and I'm going to, I started office hours late, obviously, so I'm going to go until 6:40. But instead of doing the next state equations, I could also go over parts of the next problem or just general concept questions. So what would everyone prefer? Would you prefer that I go through deriving the equations? Would you prefer that I go over something else? Let me see. I think there's a message in the chat as well. Let's see. Or not. There was. I'm pretty sure there was. How do you factor FSMs? Okay, yeah. So this is part of problem 1. So when I say when you say factor the FSMs, all that means is that you have different functionalities dealt with by different FSMs. So what we're trying to do is we're trying to have an FSM that detects 2 distinct sequences, 2 separate sequences. And so the trick for doing this is instead of designing one FSM that covers both of them, both the sequences, we design one FSM for each sequence. This is called factoring your FSMs. And so what we just did, this whole process leading up to these tables and then the next equations, that entire process was for one of those 2 factored FSMs. After you do this and you drop your schematic, then you do the whole process again for the second sequence that's on that problem. And then once you go through that whole process, you would have one FSM over on this whiteboard, one FSM over on the other whiteboard, or on the other whiteboard over here. And each of them is going to have an output, and you can use those to detect whether or not, you can use those outputs to say whether or not you had one sequence or the other. But that's what it means by factored FSMs, just splitting the functionality into multiple FSMs. Okay. Any other questions for me?
I was personally having like some problems with like the one hot on the with the like equations
Okay, yeah, we can.
because it didn't seem whenever I was doing. Sorry.
No, go for it. Go for it.
It's just because of the lag or the delay. I was just gonna say that just I was having some like the equations just I was making just didn't look right. So
Yeah, we can talk about a few of them. I can bring the camera closer. I won't be able to hold it like super steady, but I'll go ahead and hold it a little closer. I'm gonna unplug my mic for this, so you won't be able to hear me. All right. Let's see. My sound settings might have reset because I unplugged my microphones. Give me just 1 second. There we go. Okay, cool. Can one of you talk just so I can make sure that my speakers are working?
Best.
Cool. All right. So talking about the equations, I'll go ahead and do one for, I'll do next state S4 or S0. So I'll start with that one, and then we'll see how many we can get through. So this next state, S0, is only going to be on when we're in the reset state. So I'm just going to look on my truth table for all the times that we're actually in the reset state over here. So that occurs once, twice, 3 times. So for each of these, I'm going to write one term of my expression. So for this term, I'm going to write A is true and S0 is true. Then for this second term where we are in the reset state, I'm going to write that A is true and S01 corresponds to S bit 2. So A is on, and S bit 2 is on. And then finally for the last one, this is when A is on and state bit 4 is on. So it might be a little difficult to see, but I'll say it one more time. So for that first row that I pointed out, it's just when A is true and state bit 0 is true. The second one, A is true, state bit 2 is true. The last one, A is true, state bit 4 is true. And you could simplify that a little bit if you wanted to. If you factor the A out of every single term, you'd have A added with, and then in parentheses, S0 or S2 S4 or S4. But just so you guys know, that's not in SOP form, that's in POS form, product of sums form. So if you're asked, like on a test or an exam or on a quiz or homework, to do it in SOP form, you wouldn't factor it out, because then that would make it POS. Okay, so does that equation match up with what you guys got, or do you see any differences?
I have a question.
Go for it, yeah.
So what you did right now, was that like the next state equation?
Yeah, that's one of the next state equations, yep.
Or just one of it? We need multiple?
Yeah, so how many state bits do we got?
We got like 5?
So we need one for each of them. So we'd need 5 next state equations.
Alright.
Okay. So I did that first one for the rightmost or least significant bit. I'll go ahead and do one for the second least significant bit, and I'll have you guys do the rest. So we'll do it for S bit 1. And that bit's going to be on when we're at S0. Did you have a question, by the way?
I was just gonna ask if so for the equation 4, is that only whenever the left, or for, well, in this case, like whenever the leftmost bit is hot? Is that like in the
Oh yeah, for S bit.
in the next state too?
Yeah, so if you look on the table, state S0101, that is the same as saying state bit 4 is on. Is that what you're referring to?
Yeah, and so that's and that's for the next state. That's what we put for like the equations whenever that's high.
Exactly.
Okay.
So in the case of this particular next state table, you'll notice that there's only one time when we have our next state as being S010, and I think that's right there where I'm pointing to. So we'd actually only have one term for that next state equation. So that's kind of an easier one.
Okay, thank you.
Yeah, for sure. So I'll go ahead and do it like I said for state bit S1, and then I'll let you guys do the rest.
I have a question.
Yes.
For the I wasn't here for the state transition diagram, but is it still written on the other whiteboard over there or no?
No, it's not. I think someone may have taken a picture or a screenshot. So if you guys do have a picture or screenshot, send it in a chat. But I erased it. It was on this whiteboard earlier. Reason why it's not.
Oh, okay.
Reason why it's not with that one is because there's a wall. So.
Oh.
My camera over there.
The and for the state transition diagram for Mealy SFMs, FSMs, when we're going into that final like when we have the sequence, right, and we're going into the last bit of the sequence,
Yeah.
does it, I get how it's like it has the current state, or has the current input and the current output on the arc of the state transition table, but does it output when it goes into the final state or when it's coming out of the final state?
Great question. It outputs on the transition, on the actual arrow. That's when it outputs. So it's not within.
Okay, so on the way in.
Yeah. So while it's traveling, essentially.
Okay, thank you.
Yep. Okay, so I'll go ahead and finish up state bit 1. And so I've went ahead and written the next state equation for state bit 1, which has 3 terms in the truth table. Those three terms are A naught and S0, A naught and S1, A naught and S3, and you OR those all together, just like any standard truth table. So for the rest of the next state equations, it's going to be exactly the same. You just might have a few less terms in your equation. In fact, I think these two are the ones that have the most. The rest I think I'll have 2 or 1, if I recall correctly. But that's pretty much it for making the next state equations. Did anyone have any questions about that? Okay. So I just want to let you all know that I am going to be uploading this office hours lecture online with the link that I posted in the Discord. I realized this morning that there's been a problem with the recordings because the actual Discord screen that I see is not the same that you guys see. Mine's flipped. So when you look back at the recordings for the past ones, it's going to look flipped as well. You'll still have obviously the same audio and stuff, but it just might be harder to read through. So I'm going to try and fix the flipped video before next office hours. But if that is it for everyone, if there are no more questions, I will be ending office hours. So any final questions? Okay, I will take that.
Thank you.
Yeah, you're very welcome. All right, I'll go ahead and end office hours. You all have a good rest of your day.
Thank you.
Thank you.
You're
Thank
very
you.
welcome.